is intelligence first. And intelligence, according to Merriam-Webster dictionary, which actually does a decent job, is essentially you got to be able to learn or understand something, deal with new or trying situations, and then you have to be able to apply that knowledge to do something with it. And artificial intelligence is a broad category that really you can say it's a computer system that can complete tasks usually requiring human intelligence. And humans have done the learning, they have distilled the patterns, they give it to the computer or the calculator, and then the computer does what the humans said it should do. The difference between that and machine learning is that machine learning can independently distill patterns. And within machine learning, there's a specific stream called deep learning that is basically using this specific architecture called neural network to learn patterns. Here's the most simple form of artificial intelligence. It's an expert system. And essentially, humans have said, here is CURB 65 criteria that will help me determine if I need to admit or if I can discharge the patient with pneumonia. For, if the patient has C, confusion, I'll give the patient 1 point. U, urea greater than 7 millimolar, I'll give another point, so on and so forth. And you tally up the number of points, and then this naturally not naturally, but it will tell you then, do you need to, admit or discharge the patient? But this is still humans doing the learning and then telling the computer to say, okay, as I punch in the numbers, tell me what to do. The next example is machine learning, and essentially it's machines distilling the pattern. So here's a simple one, k-means clustering. Where you give the machine a series of data points and you say, hey, I have 3 clusters, tell me how they're clustered, and it will show you where the circles are. Or you can say, hey, here's a series of days that shows what Sean does. And here are a variety of factors that might be relevant for Sean determining what he does. And then the computer will then say, oh, okay, when I look at the data, it seems like there are 2 major forks about what Sean's doing on a Vancouver weekend. Does he have work? If yes, he goes to work. And if there's any cool events, he attends the events. And if not, he goes hiking, right? Those are popular machine learning techniques. But the part that is really catching all the rage right now is deep learning. And what deep learning does is that it is tremendously sophisticated and energy intensive and is really complex. And what it does essentially is that it takes a bunch of explanatory variables. For example, this is an explanatory variable about a 23-year-old with a 3-day fever, chills, cough, runny nose, sore throat. And the deep learning algorithm then takes these explanatory variables, feeds it into hidden layer, and then the hidden layer 1 influences hidden layer 2, hidden layer 2 affects hidden layer 3, so on and so forth, until it predicts, okay, this is most likely an infection or respiratory tract. So as you can think about this, like each of these little lines is a parameter. It's essentially an association between a series of variables. And the reason why deep learning is so powerful is that it's able to take billions, hundreds of billions, even trillions of variables, of parameters, so that it can arrive at very nuanced answers about what is likely going on and predict almost like what is the most likely diagnosis in this case. The generative AI and large language models is a more sophisticated version of that, and it says the autumn, and then it picks the next best word, quote unquote, and it says, oh, the autumn colors are, and then autumn colors are, intellectual or sky or red, and it says, oh, it's red. It's obviously a bit more sophisticated than that, but the intuition is basically that. It's a series of associations that are tremendously complex within this complex model, sorry.